at point 0. Over here, this is your point Y. Okay. So you join X and Z first. Okay. You cannot join X and Y. You cannot join Y and Z because Y is on the 0 line. Okay. So a Mohr circle X and Z. So you draw over here. Right. Right. So that is the lines. Okay. Or your diameter of your Mohr circle. Okay. So the first thing we're going to do is we're going to determine our stress average. Right. So stress average is equal to stress X plus by stress Z divided by 2, average, right? So this will be equal to 28.852 divided by 2. And so 28.852 divided by 2 is 14.426. Okay. So this is our stress average. So this is 15. And so 14.426. So hold on. So 14.426, I'm going to guess somewhere around here. Okay, that's our stress average line. Then we can calculate. Okay, now remember our stress average line. Okay, so this is equivalent to center of circle. Okay, then we're going to find the radius of the circle, which is equal to your maximum shear. Okay, so maximum shear is equal to, so we know the distance from here to here. Hold on. We know this distance over here, right? So this distance we knew is 14.426, right? And then the distance from here to here is 1.608. Okay, so it's just simple math. Okay, high school math. So all you need to do now is just do 14.26 squared plus by 1.608 squared. So the radius (14.515). Okay. So from here we can calculate our principal stress. Is equal to 14.426 plus minus 14.515. Okay, so 14.426 minus 14.515 is minus 0.089, and then the other side is 14.426 plus 14.515 is equal to 28.948. Sorry, 941 megapascal. Okay, so now we can construct we can sketch, okay, our Mohr circle. So I'm going to sketch this out. So 0.089 is very close to 0. Okay, and then will be 28.9. As I say, this is just a sketch. And then the shear is going to be at what? 14.426. So let me compress it a bit. Okay, so over here, this is your stress 1, and over here, this is your stress 2. Okay, now I cannot draw 3D Mohr circle over here because this circle are very close. Maybe the next one I can. So for this case, we have found that our tau max, so therefore tau max is equal to 14.515 megapascal. Okay. The hand rule of for this, do you mean thumb pointing upwards or outwards? Sao Tai, which part are you asking regarding
Yeah, you just said put the finger in the center.
Oh, yeah, so you push your finger into the block and then you rotate, you induce the rotation due to the shear stress. Does that make sense? In the Y direction.
Like, could you turn on the video to show that?
Turn on the video. Can you see
Yeah,
my
like,
screen?
I can see your screen, but I can't see your face.
Okay. I cannot turn on the video now because I don't have a camera with me.
All right, and that's okay. Thank you.
How will turning on the video help you understand this better?
You mean?
Okay, wait. If this is 2D, I put my finger into the screen, the dot, okay? So this will induce a clockwise rotation. Sorry, clockwise rotation. And this one will induce a anti-clockwise direction. Does that make sense now?
Yeah, I think.
Okay, so this is on the XY plane. Sorry, XZ plane. Can you see that?
Yeah, like you said finger, you mean all the fingers or just the thumb?
One finger, your just one finger. Okay,
Oh.
if you were to rotate a piece of paper on the table now, you just put one finger and you move the edges, it rotates, right?
Oh, yeah.
Does that make sense?
Yeah, I
Okay,
think we need to
okay,
talk
okay.
later.
So if this is your element, how about if I put a pin in the center?
All right.
Right? So this is a pin, yes?
Yeah.
Or a pin, no, yeah, this is a pin. So the pin, if you have shear stress acting this way, right? A pin means it will not resist any rotation, yes? So
Yeah.
if your shear stress is acting this direction, the square will want to rotate in this direction, yes?
Yeah.
Does
Okay.
that make
I
sense
know
now?
that. Yeah.
Okay. Okay, and then if it's the other side, the rotation is this way now. Okay.
Okay. I thought you are going to use any hand rules for that one, like bending moment.
No, it's different. Okay.
All right.
Later on, I'll teach more on Mohr circle. This is just to let you see how to calculate the maximum shearing stress and the principal stresses. Okay.
Thank you.
Okay. Thank you. It's important, yeah. Whatever you're not sure, you all have to ask. Or not, if I carry on longer and longer, you all will get more confused. I don't want that to happen. Okay. So we also know that the principal stress, okay, is equal to 28.941 megapascal. Okay. So these are the answer for element B. Okay. Then with this data over here, okay, with this information over here, then we can select the right material, right? And then we can select or calculate factor of safety, either one. Okay. Now, I want you all to next focus on element B now. Okay, I think element B, I can draw the Mohr circle, 3D Mohr circle better compared to element A because the shearing stress is just too small. Okay, so let's look at element B. Okay. I'll do this again. Okay. Okay, so this is for our element B. Right now, element B is very similar. Hold on. Element B is similar to element A in some context. Okay, so how to label the point X, Y, and Z? Okay, so this surface over here, right, is your point X. This surface over here is your point Y, and this surface over here is our point Z. Okay, so over here we know that a stress Z is equal to minus 14.989 times 10 to the power 6 Pascal. Okay, and then we know that the shear in ZY is equal to the shear in YZ, and this is equal to 18. Did we calculate 18 point? Let me be sure about this. Yeah, 18.535. Yep, 18.535. And then the rest of them, so we know that stress X is equal to 0, stress Y is equal to 0, and then shear XY is equal to shear YX is equal to 0, shear XZ is equal to shear ZX, they are all equal to 0. So again, now we can construct our Mohr circle. Okay, so I'm going to do our Mohr circle. So I'm going to start with minus 20, 18. I hope I have enough. Okay, 14, 12, 10, 8, 6, 4, 2, 0, 2, 4, 6, 8. Normal stress. Okay, so 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Okay, then our shear okay, 2, 4, 6, 8, 10. Not a good idea. I don't think I have enough space. 5, 10, 15. Not a good scale that I've done. Wait, let me do some calculation first. Okay, so 14 point. Go on. I'm still around. Okay, I'm just doing some calculation. 20. I need 20. So this scale Sorry, the scaling I've done is no good. I have to change. My apologies.